You map to the domain in which you have just a rectangular domain. Okay? Okay, so this is problem, and then this problem reformulated in terms of function which I mentioned appear as you have simple vortex at z0, and this logarithm include q exponential functions which all are infinite set of images. All set of images counted by these zeros of these functions. For q bigger than 1, because R2 bigger than R1, we have infinite set of images, and all of them corresponds to the zeros of the function. This is green function in the corresponding domain. So you have standard green function in the plane, right? And this is corrections coming from these boundaries. Okay, this is exact solution in form of the n polygons. This exact solution shows that polygon is rotating with angular frequency, which can be written in terms of q logarithm functions. This is example of Cassini mission. You know, Cassini mission was several years ago, and it is died. I mean, this to Saturn, they sent. It took north pole of the Saturn. North pole of the Saturn, you have hexagon, and this is puzzling hexagon. What is this hexagon? So this hexagon, in fact, it is set of the vortices. Why these vortices produce pentagon? So hexagon in this case. It happened because you have dynamics. So if you use Чамашер Макинасы, for example, in this Чамашер Макинасы, you should change the speed of rotation. Speed of rotation, when you change, you have different kind of polygons with triangle, square, pentagon, polygon, and other. So this means that in such type of problem, you have vortices just in atmosphere of the Saturn, and you can produce it in laboratory. Okay, now next theorem, strip theorem. So now question is, if you have strip domain, and I formulated similar theorem in the strip domain, but in this case it is used standard periodicity condition, because you don't have any type of deformation according reflection. So this is strip theorem. You have function f, which is now periodic, and bar function. If you put vortex in the strip, then in addition to this vortex, you have such logarithm of gamma function, which include infinite number of zero. This is exactly result of the when you have two parallel mirrors. In two parallel mirrors, you have infinite set of images. It is exactly similar form. And this is just picture. So I have, this is my strip domain. I have one vortex. Then you have two vortices with opposite rotation. And then you have the same direction of rotation vortices. And then you have infinite odd and even set of vortices. Okay, when Q is going to 1, this strip theorem can be appear from the two-circle theorem. Details, I don't think that it is reasonable to discuss. Then the next one, it is so-called wedge theorem, when Q is root of unity. When Q is, I forgot maybe to say that in this case, why strip theorem important? Because in Q calculus, people usually limit Q going to 1, when you have standard derivative instead of the Q derivative. Okay, so then next is Q root as a root of unity. In this case, we have this wedge theorem, which produce also set of images. This is corresponding function, and this is a device which everyone knows from childhood, right? It is kaleidoscope. In kaleidoscope, you have just wedge domain, which is from two mirrors in some angle. Then you put here some stones, everything what you like, and then you have infinite set of images which reproduce some polygon, regular polygon. So this is example. For example, you have vortex in such type of domain. Then you have four vortices with different direction of the rotations. So this is vortex kaleidoscope, which I wrote. And this vortex kaleidoscope can be written in a compact form by using identity of given by Kummer. By the way, this identity given by Kummer, he was one step close to the Fermat big theorem. Unfortunately, he was not able to prove because this factorization is not unique. This is why Fermat was not able to discover, Kummer was not able to prove Fermat theorem. Okay, but this allows us to rewrite it in such form. You have this polynomial, in this case, for function f. This is wedge in the vertex in the wedge, so this is my two boundaries. I have some vortex, then I have set of vortices producing polygons. This is case n equals 4. This is example for 3. You have trinity vortex flow. Next, I should jump more quickly. Q dispersive integrable NLS equation. So if we use generating function for Bernoulli polynomials, this is generating function. So if you expand in t power m, then you have polynomial Bm, which is Bernoulli polynomial. When x is going to 0, you have just Bernoulli numbers. So Q number, which is definition of Q number, we can rewrite by using exponential form. Q is exponential of logarithm. Then this gives you expansion in terms of Bernoulli polynomials. And this expansion can be extended to arbitrary operator A. I will speak about operator A depending on time which I have. So if you have Q deformation of operator A, you have standard operator plus this type of corrections which are polynomial in parameter A. So you have nonlinear corrections. So for example, this is Q dispersive linear Schrödinger equation. So instead of derivative, second derivative, you have Q deformation according to this formula. It means you have Schrödinger equation with such nonlinear deformation, which include infinite set of dispersions. But infinite set of dispersion, we know in integrable systems, you can compensate by nonlinearity. This is called recursion operator R. So this is why you have, for this type of Q dispersive nonlinear Schrödinger equation, using this technique with Q here, but it is symmetrical calculus. Then you have standard nonlinear Schrödinger equation, complex conjugate, and these are infinite corrections coming. What is interesting, all of them exactly integrable by the spectral transform method. So these are exactly soluble models. Okay, next part, quantum calculus with operators in quantum theory. So now in Q calculus, if we look for the theorem which I was telling, scaling with Q, you can write as application of operator Z dz. This operator is scaling operator, generator of the scaling. So this is why you can rewrite in operator form. But this operator form implies that you have Q number, but Q now is operator. So according to this, we can reformulate now this Q periodicity for the quantum theory. So according to this, we have Q power n, n is number operator. Then this is eigenvalue problem for this number operator. In special representation, I have no time to discuss it in detail, but in quantum theory, there exists special representation in terms of complex analytic function. It's called Fogg-Bargman representation. So this is why quantum states you can study as analytic functions, okay, and operator acting on analytic functions. So according to this, I reformulated in quantum theory Q periodic state, quantum states, like this. And this is set of the self-similar quantum states, which are, you see, with Q with different n here appearing. So this set of states is self-similar states. Then I reformulated in quantum theory wedge theorem. So wedge theorem, so you have quantum state psi. Psi bar, it is when you have complex conjugation. This is, let us say, relation between complex functions and the inner product in the Hilbert space. Then you have this type of complex functions which describe this quantum state as a mod n analytic functions. So this is formulation of this theorem, but let me move forward. So generic case of kaleidoscope states is written here. So you have set of these states. This is normalization constant. This is Hadamard matrix, which is used in quantum computations. And this is corresponding kaleidoscope states. So this is kaleidoscope decomposition. It is related, this can skip part, clocked and shift matrix by Sylvester, because this is related with so-called quantum groups. Let me, how much time I have? 5 dakika, tamam. Let me just briefly to complete the poster of this meeting. So golden quantum calculus. So interesting point is following. That Fibonacci number everyone knows, I don't need to introduce. But what is interesting, Binet introduced formula to writing Fibonacci number Fn in terms of the golden ratio, and phi prime it is silver ratio, let us say, which is written here. So in this sense, this is calculus, quantum calculus with two parameters. PQ calculus it is called. I didn't write in detail because no sufficient time. But according to this Fibonacci number, it is just Q deformed number with two parameters, phi and phi prime. Then we can apply Q derivative, the Fibonacci derivative, let us say, I called it golden derivatives, integrals and all other stuff. Okay. Then, since n is here integer numbers, we can extend this formula to operators. N is number operator now, then it's become Fibonacci number operator, which is acting now to quantum states. So this is relation between operator, golden derivative, and this type of deformation. Okay, then next generalization of Fibonacci number, it is coming from the following fact. If index of Fibonacci number is product of Kn, then this Fibonacci number is divisible for Fk, of course of Fn also. Since it is divisible, it is integer number, which call it Nk. First, we call them higher Fibonacci number, then more exact Fibonacci divisors. According to this, I developed calculus, all this calculus derivative and quantum version of this calculus. So this is example, for example, recursion formula for these Fibonacci divisors. You see you have Lucas numbers here, and so it is different from the standard Fibonacci rule. Addition formula is also different. Fibonacci numbers and quantum coin flipping. Fibonacci number appears in the coin flipping problem, which was introduced a long time ago by Moaver. He discussed what happens if I do coin flipping and only at the last two steps I have head-head. Then I reformulated this problem in quantum theory. So if I have quantum states, then it can be after measurement with some probabilities P1, Pn, jump to this state from x1 to n. I have random quantum state. So in this case, I have quantum coin, and this is important problem, quantum coin flipping. So this is how this coin flipping arranged by X gate. So then let me show you. So I have, this is the quantum state 1, 1 at the end, but all of them before not include any pair of 1, 1. Okay? So then if, this is Fibonacci tree for adults and baby rabbits. I have the same tree, but for now for quantum states. Okay, instead of baby and adult rabbits, I have now 0 and 1 states. Okay, and then probability in this case is counting number of states is proportional to Fibonacci numbers. Okay, so this problem, if I look for the states with n and n plus 1, ratio of probabilities in the limit give golden ratio also. You can calculate Shannon entropy, level of randomness for these states. Then different position of this 1, 1. I can put it on the some position k. Then I am counting to the left and to the right probabilities, applying, and then I have this product of Fibonacci numbers. And this can be extended to general case. I have, you see, bipartite, multipartite states, quantum states, with 1, 1 at the end point. Then calculation of probability in this case produce product of these Fibonacci numbers. Okay, this is, I called Fibonacci garden such type of states. This is generalization. This let me skip. Let me last 1 minute. Last minute to say that, okay, now I will replace number n by such type of matrix number, which is called supersymmetric number operator. According to this, I have supersymmetric Fibonacci operator and Fibonacci. So these are quantum states corresponding. What is interesting in this case, this state now become entangled. Entanglement, it is most important property of quantum computations. So state now, because I have now matrix form, are entangled. Entanglement characteristic given by in terms of the gram determinant of inner products. So this type of calculations, Sonochta, you have uncertainty relation in terms of the ratio of Fibonacci numbers. So finally, let me say following. Quantum, of course, you understand that this is reclam, basically, because impossible. Every step need one lecture. But I was trying to show you following, that quantum calculus, which is started from simple formula written by Euler, Ramanujan, not simple formulas, but complicated, can be interpreted. And always I am looking on the formula of Ramanujan, I try to interpret it from the point of view of the geometry of the hydrodynamic flow or quantum theory. So, that's all. Thank you very much for your attention.
Hocam teşekkürler. Şimdi klasik türevde biliyoruz ki işte bir noktadaki türev o noktadaki teğetin eğimini veriyor. Ya da işte yolun zamana göre türevi hızı veriyor, velocity. Ya da hızın zamana göre türevi acceleration veriyor. Peki burada mesela Q türevin bir geometrik ya da fiziksel bir anlamı var mı?
Türkiye otoban yollarında yeniden şey çıkmış, ne diller ona, ortalama yapılar, doğru mu?
Ortama hız tespiti.
Bu da onun böyle farklı bir ortalaması.
Yani farklı steplerde evet, ortalama.
Normalde ortalama siz hatırlıyorsunuz giriş çıkış, right? İntervallar. Burada Q olacak şeye göre. Belki gelecekte kullanılır. Ben
Q bir alınca evet klasiğe dönüş.
Quantum calculus is calculus without taking limit. Finite difference calculus. Normalde evet Q difference çarpırsınız. Fermat partition ben söyledim ona. Ona göre Q'ya göre çarpırsınız.
What was why in the last slide? The uncertainty principle.
This one? This is uncertainty relation in supersymmetric golden calculus. So it is given in terms of the golden ratio. So in this sense, at quantum level, when you do quantum engineering, you can create golden ratio, which is normally we are using human proportion, for example, right, and others.
Hocam, Q derivatiflere göre bir Schrödinger denklemi yazmıştınız. Orada bir correction terim vardı.
Evet.
Yani deterministik modeller aslında gerçeği tam tamına yansıtmıyor. Bir approximation. Bu sizin yeni tanıttığınız bu derivatife göre elde ettiğiniz o correction içeren Schrödinger denklemi deterministik modele göre daha iyi bir sonuç mu veriyor?
Tamam,
bu anlamı mı geliyor?
Tamam, let me tell you. I wrote similar way relativistic Schrödinger equation as a deformation of the non-relativistic. Because siz söyleyen Schrödinger equation ikinci derece. It is so-called non-relativistic Schrödinger. Relativistik olanda, because orada momentum karesi var. Relativistik olanda you have square root of p kare. Ona göre you have infinite power series in p square. According to this you have infinite number of derivatives. So it is infinite derivative equation. Ona göre in that calculus I can write. Onu ben yapmıştım. Even nonlinear Schrödinger yapmıştım ona göre.
Evet. Buyurun hocam.
Şimdi Oktay hocamın da sorusuna belki cevaben, şimdi normal türev limitle tanımlanıyor. Türevin limitle tanımlanmasının temelinde hareketi modellemesi, harekete değişim var. Zaman söz konusu. Kuantumda ise bir sıçrama, kuantizasyon söz konusu. Yani bir şey söz konusu değil, bir süreklilik, noktasal bir davranış söz konusu. Dolayısıyla limitsiz tanımlanmasının şeyi bu, sebebi.
Geometrik
Değil, kuantizasyon hocam. Kuantum derivatifdeki şey bu. Nasıl hocam? Teğetin türevi, orada teğetin türevinin almasında evet, orada bir süreklilik limitle veriliyor o teğetin davranışı. Onun sebebi türevin sürekli bir hareketi modellemesi. Ama kuantumda bir sıçrama, yani en kuantum parçacıklarında sıçramalar, kuantizasyon söz konusu olduğundan bir lokal süreklilik söz konusu değil.
Evet, orada limit yok, onun için uncertainty relation var, ona göre. Evet.
Evet, başka soru soran. Hocam teşekkür ederim.
Ben teşekkür ederim.
Profesör Doktor Sayın Oktay Pashaev'in sunumu için teşekkür ediyoruz ve plaket takdimi için Profesör Doktor Sayın Nergiz Bayram'ı tekrar kürsüye davet ediyoruz.
Evet hocam, önce bunu ağırmış hocam. Hocam önce bunu takdim edelim. Evet.
Tamam.
Sonra da şimdi böyle.
Evet.
Işte,
Bu da bir circle, yok iki circle teoremi bu, doğru.
ha, böyle mi? Böyle tut.
Evet, iki circle var.
Ha, öyle mi?
Evet, gördünüz mü?
Ha, doğru. Tam sizin konuşmaya göre. Evet. Hocam teşekkür ederiz.
Ben teşekkür ederim, çok sağ olun. Evet.
Kapatın hocam. Bundan sonrası siz ayrı. Teşekkür ederim. Sağ olun.
Değerli konuklarımız 15 dakika ara ardından program amfilerde devam edecektir. Teşekkür ederiz.